In this video, I'd like to talk about the formula for a finite arithmetic series, and specifically how that formula is derived. So you can see we've started with a general sequence, where A, that is our first term in the sequence, D is the common difference, the number that we will add or subtract when going from one term to the next, and n is the number of terms in the sequence. And with this general formula for the sequence, we can build a series from that where we actually add up every term in the sequence. And like I mentioned, what we want to do is find a formula where if we're given any starting term, any common difference, and some finite amount of terms, that we can always add it up using the formula. So let's first just get a general idea of how this formula works. So let me make a little bit of space here. So let's say, for example, that A is 2, our common difference D is 3, and we'll say N is 5. So in that case, we would get a sequence starting at 2, that's our first term, and then every term after that we're just going to add 3 repeatedly. So the next one will be 2 plus 3, which is 5, and then the next one after that, based on our formula here, it's 2 plus that common difference twice, or you can just start at your second term and add the common difference to get to your third term. So 5 plus 3 is 8, but you can see that works in the formula since 2 plus 2 times 3, or 2 plus 6, is also 8. And all the way to the last term in the sequence, notice we have n minus 1, and there are going to be n terms. Now, in reality, this first term is plus 0d. So for the first term, we're just adding that common difference 0 times. And here it's 1 time. So for instance, this is term 1, term 2, term 3. So notice that we're adding the common difference always one less time than the total number of terms. So that's why this is n minus 1 rather than n. So the last term in this sequence here, we would have 2 plus 3 times n minus 1. Let me make just a bit more space. So this would be 2 plus 3 times n minus 1. And of course, the series, we're just going to add all these together. So 2 plus 5 plus 8. And then we keep adding all the way to this last term, 2 plus 3 times n minus 1. But for this video, we don't want to talk about a specific series. We want to talk about this in general and then derive a formula. So let's go back to this general series here. And we need to come up with a technique to be able to add this up. And the general idea, so we can call this S for sum, and actually, let's call it S sub n, since it's a sum with n terms. And let me clear this out since that's just our example. So like I mentioned, we'll call our general arithmetic series here equal to S sub n, where n is our term number. So there are going to be n terms in this series here. And the technique we'll use to actually add this up is we're first going to rewrite this backwards. So we're going to take our same sum and just copy it down so that instead of having a first, we're going to have this last term first. So let me make a little bit of room, and then we can actually write that down. So all I've done here is just rewritten the exact same sum, but in reverse order. So I started with the last term, the term before that, and then all the way down to the second term and the first term. But it's identical to the one up top, just rewritten in a reverse order. And the reason we want to do that is now we can add these two together. So we're just going to add basically our sum twice. So we're going to get twice S sub n. But we're going to see a nice pattern when we add these together. So notice when we have a plus d times n minus 1, we're going to get twice a plus d times n minus 1. And for this next one, we'll take a plus d times n minus 2. And if we were to actually distribute this, we get a plus dn minus 2d. So when we add these together, we'll still get a plus a. We'll get 2a. But now we'll get dn here. And we have d minus 2d. So that would be minus d. And we'll be able to rewrite this as 2a plus d times n minus 1. Notice it's the exact same thing here. And we'll keep going. This is going to go on for a while. We do have a finite amount of terms, but we're assuming there's many terms in the middle here. And they're all going to simplify to this 2a plus d times n minus 1. So remember that the term before our last term, so the term that would go right here, would just be a plus d times n minus 2. And we're going to add that to our second term. So our second to last term and our second term will add together. But we did that over here. The a plus d times n minus 2, those added together, and we got this simplified expression. So we got 2a plus d times n minus 1. And lastly, we add the first term and the last term, but we already did that over here. We know that that's just 2a plus d times n minus 1. So we'll get that one more time. The 2a plus d times n minus 1. It's a little crammed there, so let me rewrite all this. And just to complete the pattern so that we can fully understand this, let's look at adding the third term to the third to last term. So we'd be adding a plus 2d and then adding a plus d times n minus 3. And we can add these together if we distribute the d to both of these. So notice we get a and a, so that's 2a. And then we also have the 2d there. We have d times n, so plus, we can just say nd. And then d times negative 3, or minus 3d. But you can see this is just 2a plus nd, and then 2d minus 3d would be minus d. So 2a plus nd minus d, or d times n minus 1, since notice you get nd and minus d there. So this would also simplify to the exact same term we got when we were adding the rest of them. So the first and the last make 2a plus d times n minus 1. The second and the second to last make the same sum. The third and the third to last make the same sum, and so on to where you get to the end and you're going to get the same terms. So basically we're adding this same thing over and over and over again. In fact, there's going to be n of these. So we can rewrite this sum as n times 2a plus d times n minus 1. And this is equal to twice the sum of our finite arithmetic series. And it should make sense why there are n of these, since if we look at our original sum, there are n terms. This is 1, 2, 3, all the way on till this is the last one, which we called the nth term. And so there were n different sums. They all added up to that same amount. And so if we're adding the same number multiple times, or n times, that's the same thing as multiplying by n. So let's go back to what we're able to sum up and try to simplify this. And if we want to get our sum by itself, this s of n, let's just divide by 2. So our total sum for our general arithmetic sequence is n over 2 multiplied by 2a plus d times n minus 1.